Hello everyone, my name is Jiejun. The paper I'm going to introduce today focused on how to build up the NB-IoT environment. The topic is prototyping of open source NB-IoT network. This is the agenda for today's presentation. I have divided my presentation into 4 parts. First, I will introduce the background for the open-air interface and NB-IoT. Secondly and thirdly, I'm going to show the steps for build up the NB-IoT base station and how to configure the NB-IoT module. Last, I will play a video to demonstrate how the NB-IoT base station working with the UE module. Let's begin by the introduction for the OAI and NB-IoT. What is OAI? Its name is Open Air Interface. It is an open source and have implemented the latency LTE standard from GLOBECOM. It provides the environment to develop and do more research in the telecommunication. Then what is NB-IoT? The Narrowband Internet of Things. It is also a 3GPP standard defined to support massive machine-type communication service. To support the IoT device but not occupy all the bandwidth, so the industry decided to make it narrower. Narrowband, it means only have 180 kHz in the frequency domain. And the industries also decided to time domain boundary. It means we can use the most of time domain designed as the latency LTE and utilize the systems in the various situations, including in-band, guard-band, and standalone. And in this paper, we will present the standalone mode. For the implement the NB-IoT base station, last year, we had a project to develop the protocol stacks in the OAI and co-work with Beacon and Eurocom. This project focused on the design of MAC layer for the base station. And you can see here, the MAC layer, we have our own scheduler to schedule all the downlink and uplink data. And all the downlink uplink channels only support the mandatory NB-IoT features of control plane solution. And for this paper, the main contribution is to present the method to deploy the NB-IoT environment. Researchers can duplicate the open source NB-IoT network environment in their laboratories. This work means can be a starting point for the researchers to contribute to the open source community to support 5G massive machine type communication service. And this is the software and hardware requirements for our testing environment in this paper will show. And if you want to try by yourself, you can follow this table to prepare the software and hardware. Well, the next slide is about the step to install the NB-IoT base station. The deployment environment is based on the Linux systems Ubuntu 16, and the hardware we used is USRP B210. To build up the base station, everyone can pull the source code from the OAI GitLab and check out to the branch to develop NB-IoT. The latest commit is the stable one, so you can just follow the command line to compile the source code. To run the NB-IoT base station, we also have to copy the configuration from the project dictionary. And this configuration is which you can use for the NB-IoT base station. And they have some parameters in the configuration. They should be same as the left side, but for the right side, the MNE parameter and network interface have to be set up to your environment. The MNE IP address, and it should be your co-network IP address, and the ENB interface, it should be your NB-IoT base station's interface and IP address. This page shows the network connection between our InnoB and the co-network. After you modify the IP address in your configuration file, and you can run the base station by the LT soft modem and call your configuration, and it will show the right figure, and until the base station run the gut sync, it means the base station is waiting the UE to connect with it. For the UE side, we use the NB-IoT module from the Quartel. There are two modules we have used. One is BC95G and the other one is BC95B28. In here, we only present the detail for the BC95G module. And the other module setting have also described in the paper. And if you want to see, you can check the paper for the detail. For the UE side, we use the NB-IoT module from Quartel. There are two modules we have used. One is BC95G and the other one is BC95B28. In here, we only present the detail for the BC95G module. And the other module setting have also described in detail in the paper. So if you want to see the detail about the BC95B28, you can check the paper. And so here we only present this one. First, we should install the UE monitor. This tool is provided from the Quartel, and we can use this tool to command the UE module to control it and see some detailed information in the UE side. Second, and we have to run the UE monitor and to connect to the debug port, and it can let us to analyze the UE information in the UE side. Third, we should connect the main port, and we can control the module by the AT command. And these AT commands are we used in here. To reboot the UE module and setting the configuration and lock the frequency and to attach the co-network. And you should do this AT command in order when you open your base station. And to see the UE message in detail, we can use the filter to see the different message. The RC debug ASN, it means we can see the RC layer in the UE side and to see what UE receive and send. In here, for example, this message is the zip1, and this zip1 is sent from our base station. And the other filter is NAS DBG NAS message. And for example, here we can see this message can show what message type the NAS decoded. Last is the demonstration. Before the demonstration video play, I have to explain the terminal what it means first. The first one is the OAI NB-IoT base station, and the second one is the core network, and the third terminal is about the packet between the core network base station and UE, and the fourth terminal is the BC90G, and we can see the UE log here and the AT command is in here. Okay, in this video you can see our core network have already up, and we try to upload our base station. And the first message you will see in Wireshark is the S1 setup. It means the base station have already connected to the core network. Okay, after the base station is prepared to connect to the UE module, we should to control the UE module to send the connect information to the base station. So in here, we try to reboot the UE module first. And to see the UE module's configuration. And also lock the frequency. Why we should lock frequency in here? It's just to reduce the time to let UE to connect to the base station. After lock the frequency, we should do the attach procedure in here to let the UE know you should do the attach procedure now. Okay, you can see when the attach procedure during the UE and the base station, we can see the Wireshark layer have a lot of clearly information. We can see this is the all attach procedures information, including identity request, authentication request, and the security mode command. And after the attach procedure, it means we can transmit the data. So we use the AT command to send a ping data to the core network gateway. And we also can receive the ping reply in here, and we can see this in the Wireshark. Finally, this is the conclusion for today's presentation. From the previous video, we can see the base station can successfully pass the random access procedure and attach procedure. And after the attach procedure, we also can do the ping request from the UE side and successfully get the reply from the core network. But there have a remaining issue in our base station. It's about the file decoding. During the attach procedure, all the uplink data transmit from the UE side, the base station will have a decoded value for the specific data byte. And in here, we use the hardcore to solve this problem, but we still have to solve this problem not using the hardcore, because after the attach procedure, the UE should send the data to the base station. If the data size is too big, it also have decode failure, so it will be a problem in the future. So this issue we're still working with the GLOBECOM. And thank you for your listening.